Welcome to the Navic Gaming Podcast, where it is our mission to explore the business and future of video games. We bring together the industry's brightest builders, investors, and thinkers to keep a pulse on current events, dissect emerging trends in games, share lessons learned, and have a great time. This podcast is also part of Navic's growing ecosystem, which ranges from free and premium research to consulting and advisory services. For more information, visit www.navic.co. This episode is brought to you by Listo. Listo is an AI-native playtesting platform helping game studios capture unbiased player feedback and convert it into structured, actionable insights. Whether you're validating new features or catching US friction before launch, Listo empowers the entire game team to move faster with clear insights and less guesswork. To learn more and get in touch, visit listo.gg or check out the link in the show notes. And with that, let's jump into the episode.
What's up, everyone, and welcome to the Navic Gaming Podcast. I'm your host, Alex, and this is the interview and insight segment. This is my last episode of 2025, and I'm excited to be closing out the year on something big and bold: world models and embodied agents. World models are suspected to be AI's next major frontier. Unlike large language models, which describe the world through text, world models aim to understand how things move, interact, and evolve in space and time. There's tremendous potential for breakthroughs that will impact robotics, defense, and anything touching physical space. We, of course, know that video games have often been the vanguard for advances in 3D space. And so today we'll be discussing world models as they are derived and applied to gaming. A company with a unique advantage, billions of gameplay videos, has emerged to tackle the space. Backed by investors like Rain, General Catalyst, and Khosla Ventures. I believe this is actually Khosla's largest seed check since OpenAI's in 2018. Our company of subject today, General Intuition, recently raised a $133.7 million in seed funding to fuel its ambitions to be a premier research lab in the game space. And my guest today has actually graced our airwaves before, but given what we're discussing today is so different, we just had to have him back before closing out the year. It's my absolute pleasure to welcome Pim de Witte, founder and CEO of General Intuition and Metal, to our airwaves today. Welcome to the pod, Pim.
Thank you.
It's good to see you
I'm
again.
glad you got the joke on the number.
Yes.
Most people didn't get it.
I say it very specifically. I've been told this is a very specific number, and I have to say this specific number. Perhaps for those in the audience who don't get it, what are they?
1337 is like it's gamer elite speak. You gotta, I mean, if you don't know that, you should probably stop listening to this podcast.
Okay.
And go play some video games.
Sounds good. Well, this is my last episode of the year, and I'm glad I'm going out in a banger. I know you've been traveling a ton. You recently spoke at AI Pulse, and you've been doing this big podcast circuit. Do you have a highlight so far? What's been your favorite thing that you've done the past 2 weeks?
Oh, it was definitely the keynote with Yann LeCun.
Mm-hmm.
That for me was I got the invite pretty randomly, and I wasn't expecting it. He's obviously a legend, and I'm not. So it was pretty surreal to do there was like 1,500 people in the audience. The rooms were overflowing. That's always what happens when Yann does a keynote, by the way. So it was definitely there because of him, not me. But it was like, and also he's super technical, so it was quite intimidating. And like he has a Turing Award level technical. So it was pretty. It was good. I was pretty nervous, but it worked out super well, and a lot of people watched it, so I'm excited.
Amazing. Yeah, and it's always good to meet your heroes. But so you've already been on our show before, and so I'd like to do a slightly different intro process. I'll just ask some questions to help the audience get to know you, and then we'll dive right into our episode today, which will be packed full of information. So you've done a ton of developer and engineering stuff in your background yourself. You created the largest open source Unity package. You co-created Unity Firebase. You started the largest RuneScape server, I believe, SoulSplit, and you made like $1.5 million in net revenue doing that. I watched some YouTube videos of someone interviewing you when you were really very young. You're clearly quite precocious. Can you just explain why you like doing all of that? What kind of motivates you and drives you to sort of have built so many of these foundational servers and packages from scratch?
Yeah, I think the packages are usually because I'll spend like 6 or 7 hours debugging something during the day, and then that was the Unity main thread dispatcher. That was the origin of that. And then I was like, oh, I don't want other people to have to go through this, so let me just publish my solution, something in like a pretty nice way. Like at the time, Unity just didn't have a good way to dispatch anything to the main thread, which was required for like manipulating the UIs. Like if you wanted to do callbacks from Firebase, it led to like UI changes, which we used for like matchmaking. There was no way to do it. You had to like custom write the stuff. So anyways, it's mostly just about giving back in a way. I mean, my personal motivation is also largely driven by impact. So I think that both that is true, but I also think that building good companies and making money is a kind of right in a way that you get to deploy how to use that. So like, pursuing science. So to me, I think it's a form of like pursuing your ambitions. So it's not necessarily about making the money, it's about getting to do what you want to do and taking the bets that you want to make. And for me, those tend to be pretty large. And so that has required like increasingly larger businesses to be built. And I think, so yeah, it started with my private server. Then I did that for suborders for 3 years. And then worked on Ebola and satellite-based mapping. And then eventually started Metal. And then, from Metal, General Intuition.
Yeah. And that actually brings me to my second intro question, which was, until General Intuition, you were at the helm of Metal, which we are going to recap for the audience that didn't listen to your previous episode this year in a moment. But you were doing that for about 8 to 9 years. And so I love this game that I play with some of my friends, but it's called the Rosebud Thorn. The rose was something that was amazing about those 9 years. The bud was something that you're excited about or you're on the cusp of. And the thorn is something that was just like a total pain in the ass the whole time. For those 9 years, what is your Rosebud Thorn for Metal?
Okay, so I guess mine would be during COVID, for many teenagers, it's like the only way to actually create beverages with friends. So we saw a lot of memories being created during COVID, which was like the only way to do it. And I think that's one thing I'm pretty proud of on Metal. Like the Fortnite concerts, all those things. Like for an entire generation, there's definitely like most of their memories with their friends live on Metal. Mm-hmm. It was also a huge inflection point for growth. The Thorn, I guess two things. One, acquiring teams with like really good products and not realizing how fast technology stack itself was going to change. Like for instance, we acquired a company that, and this was not their fault, that did really good editing. They had a really good editing software that we built it in product, and then it was really, really great for like 6 months. It was slightly different stack, so it was more difficult to maintain. And the team eventually just, in retrospect, we should have just like written it from scratch. And so then people didn't want to work on it, and the editor kind of like lagged behind for a little bit because I had made that acquisition. And so, and by the way, the team's great. This was entirely on me, not on them. But yeah, so the thorn is that I underestimated how fast technology would accelerate both inside the company and outside the company, how fast the ecosystem around video and React would mature, for example, because that wasn't the case then. So when making acquisitions, I need to be better at like predicting the trends I'm making acquisitions behind, as opposed to looking at it as a moment in time. So the thing I'm excited about right now is how much I think gaming is going to positively change because of the acceleration of AI. I think we've been kind of like stuck for a while, to be honest. And I think that I think the industry has needed like fresh blood and new studios for a while that can ship quicker at the pace of like, TikTok, right? Where like culture changes by the day. And it does feel like as a games industry, we're still sort of stuck on those like 4-year cycles. And like, I think AI just changes that very rapidly. And so I'm pretty excited about how quickly things are going to change. And I hope that leads to a ton of growth for the games industry as a result, because we sort of see more of the attention going into the studios that just ship a lot faster.
Awesome. All right,
Yeah.
so this is perfect segue to go into our first topic, which is we're just going to do a quick 5-minute recap on the episode you did earlier this year for our audience members who might have missed it, or need to do some reminiscing. But metal is really the foundation of what you're building at General Intuition. So I'm going to ask just a few questions that'll inform context for today's discussion. And so the first thing is in like just a couple sentences, like what is metal? What is metal?
Metal is the easiest way to record and share video game clips with your friends. So it's always running on your computer. You hit a button, it syncs the last 15, 30, 60 seconds to your phone. You get a link and you get a profile, and you can easily connect with your friends around the stuff that you're experiencing inside video games.
Mm-hmm. Okay. So it's kind of like combines a little bit of like the social stuff of obviously like a TikTok or YouTube, and then it's like OBS Studio together.
TikTok. Yeah, I would say that the reason why it's so special is because it has none of the complexity of something like OBS.
Yes, which is very complex.
Other than that, as an analogy, I think it's pretty good.
Cool. Yes, very much less complex OBS Studio. Someone who's used OBS Studio, it's very hard.
If you ask metal users to describe it, I think they would tell you it's like closer in between like Snapchat and Instagram. Closer to the Instagram side, but there is a large public graph, but actually most people use it with smaller groups of friends.
Okay, cool.
Yeah.
And so then second, what is special about metal that makes it different from other large catalogs of game clips like YouTube or maybe TikTok or Instagram? What's special about metal?
If you're trying, so TikTok has a problem that it's not 16:9 video, so everything is kind of cut to like this very, very narrow. So that kind of disqualifies it for training any sort of system. YouTube has the issue that so for instance, you first have to account for pose estimation because most YouTube videos are recorded on like a mobile phone. And when you're training foundation models for robots, like we are, you actually cannot use the, you have to actually stay in the same perception as like a robot would, which is usually first person. And so you have to pose estimate back towards for first person, which doesn't necessarily generalize well in very complicated environments. Then you have to account for action labels, which like the actual actions that people take. And the problem with that is that humans are really bad at labeling these things because they are very fast. They're like millisecond precision actions usually. And because of a metal recorder, we get these automatically. And people also like to overlay that stuff on like their videos and navigate clips by like which actions you took and things like that. And then lastly, you have to account for optical dynamics, so basically eye movement. And the cool thing about like if you think about YouTube, every single time, every single second, if you don't know where your eyes are looking, you don't know the decision that you're making, whether it's based off something that's not inside sort of the pose estimation view. And so if you're looking left, you're looking right, then you don't have like a complete information loop because something might be happening outside of view, and then the model will learn to correlate nothingness with like making decisions, which is really bad. And so with video games, you kind of simulate optical dynamics with your hand because you control sort of the head and eye movement as one unit with the mouse. And so it's actually a much better representation of spatial temporal reasoning than even YouTube videos. Mm-hmm. And so our bet is that we can really focus on those dynamics that you can see in video games, and then use that as a foundation, and then train with other elements on top of that.
Okay. But I think in general, let me just repeat in maybe a fifth grader way what you just said back to you, which is that for metal, unlike YouTube, which is like anybody could be doing anything outside, skateboarding, watching a dog. Metal is mostly a video game platform, and in addition to users using this clipping tool, you also have captured basically the 3D contextual data of their keystrokes or their controller strokes, so that you know what the player is doing and what their intent is. Is that generally correct?
We don't capture the actual controller or key inputs. We convert them to action labels in memory. So you never actually capture a key or anything like that. And the reason is when you train these models, you don't need that information. It's actually noise. At training time, it's complete noise.
Yeah.
Because you don't want the model to associate something like typing with the action, right? So you actually want to convert everything to action labels. And that also leads to a much better like privacy situation.
Okay.
And so, but that isn't like just having that is enough. Like this is obviously something that YouTube can do, but just to be super clear. And so so you then once you have the action labels, and also we don't scrape like Metal is 2D, so like you get frame information in 2D, and then the action labels from the user. And that is enough of a loop to kind of bootstrap this.
The 3D contextual data. Yeah. So maybe sorry. So you're not capturing players hitting W, but you're like in WASD, you're like player moving forward, going forward.
Yeah,
something like
exactly.
that.
Exactly. Yeah.
Okay.
Exactly.
Yeah, and that's really valuable. And so I think the reason
and it never captures anything that's not in action, essentially.
Makes sense. Okay.
Yeah.
Cool. Yeah, and I just wanted to lay that ground because I think so many people have been like, oh, well, like, can't you just train 3D world models off of like the gaming stuff that's on YouTube or the gaming stuff that's on TikTok, and making that meaningfully distinctful with I forget, you have like 2 billion clips or something like that, right?
It's a billion uploads a year.
Billion uploads a year. Okay.
Yeah, which is roughly equivalent to YouTube. Obviously, YouTube has more minutes per upload, but it's in terms of upload count, it's roughly the same.
Okay, cool. All right. So that's Metal in a nutshell. And so you have this insanely unique data set. And this year you raised 133.7 to build world models and embodied agents. And so before we start talking about what world models are and how they could be applied to games and industries beyond, I kind of want to understand when you started even thinking about general intuition. You turned down this bid from OpenAI for about $500 million, from what I understand. Were you planning to do general intuition before that bid? Like, when did you start thinking about general intuition existing in the cycle of Metal's 9 years of existence?
I can't comment on OpenAI specifically, but I can tell you like broadly related to lab discussions and why we decided to stay independent. General intuition, I think the thought process started mid 2024, and a lot of that was due to like a bunch of papers coming out at the time. Like you had the first GD paper, you had the Diamond paper, and it became very, very clear that this combination of actions and observations, like actions and frames, are sort of the loop you need to bootstrap this like intelligence for world models and embodied agents. And it also was very, very obvious that sort of we were sitting on the right kind of avenue to pursue that. And I don't think any other company had that same path, which is why I was really, I was already really interested in AI in general. I had read all the papers, or not all of them, but many of them surrounding transformers, and I had built models before when I was at Doctors Without Borders. So for me, it was kind of like a natural, a natural move to start exploring it. We didn't expect that it would escalate so quickly. I think for us, we were really just exploring it, and then indeed, like a bunch of companies all of a sudden started inbounding for acquisitions, and so for us that was very unexpected, and this actually it was funny the time between us agreeing on a board level to kind of start exploring this and all the craziness was there was 2-week period in between, so it was all super fast. And all over Christmas and stuff too. So it was a really crazy year. So then 2025 is when it really materialized. So we built a research team. We actually built the foundation models. They look great. I think you've seen some of them in the office. So we also didn't expect how fast we'd be able to make progress, I think. So it's, I think it's been 1.5 years in total of actually pursuing this. It also took a long time to get all the labels for the actions in the games, right? So we had to have people actually create those. And we didn't want to collect any of the data without them because it would cause privacy issues. So 1.5 years of really heads down work, and then we just announced after a while, after we really knew that we were in a really good spot, essentially.
Interesting. Okay. So collectively, it's kind of you were on the side, passionate about it, and you started reading all these papers, and you're like, hey, actually, maybe the thing that this other company that I'm running could apply to to building.
Yeah. It was a total accidental find, to be honest. Like, I actually tell people it was worse than accidental because actually when I was at Doctors Without Borders, I was a contractor at Google Crisis Response, and I was working on the same floor as the DeepMind employees for a while, and I would have lunch with them, and I would learn about what they're doing and how they believed in like video games as like, you know, a path to their version of AGI, and I think at the time I thought it was really silly. And then when I built Metal, I didn't think back on that once. I didn't connect those dots. I didn't like,
It's fascinating.
to be honest, until these papers came out. And so, yeah, it's worse than luck, I will say. But I'm glad we did it.
Yeah. That's an amazing story. And I'm sure that a year and a half it seems like it's a short period of time, but as I always say, it's not about years, it's about effective labor hours. And so I'm sure that in that year and a half, you've done a lot of work.
Yeah.
And so I think this is a perfect way to dive in. You know, we understand the journey from Metal to general intuition. And now I'd like to start talking about maybe some grounding on world models, like what they can do, what they can't do, and how they're being built. So the first is, what is a world model?
Yeah. So world model, you can kind of think of it as a video model. So a video model is a model where you maybe give it a text prompt and it predicts the frames that are related to that text prompt, and then from the first, it will initially generate the first frame, and then using the first frame and the text prompt, it will generate the second frame and the third frame and the fourth frame. It's all descendant from that first frame. A world model, however, has to generate the entire distribution of outcomes in those frames, depending on the action that you take. So it's a bit of a more complex problem, but the architecture is similar to video because it also generates the frames. But instead of generating frames sequentially in a video model, it does so where you can actually interact with it, and as you're interacting with it, it generates the other frames. I like to describe it a little bit as like you know, when you dream, often you're a bystander and you see things and you can't do anything. That's kind of like a video model. A world model is where you could actually then go in and do things and interact with everything, which is fundamentally how humans learn. And so that's why world models are important too, because humans don't learn from just observing and watching videos that are generated. They actually they learn from interaction. And that's, I think, you know, the reason why everyone's betting so big on world models, because it's a very general, especially if you have a lot of the real world already represented inside those video models, it's an incredibly general way to make everything interactive and learn from everything that's on the video data on the internet.
Okay. And just to distinctly say, what is different about a world model from an LLM?
Yeah. So I like to describe, have you seen Frozen, the movie? Okay, I like to describe LLMs a little bit as like a snowball. So it starts really small, and then what LLMs do is they're autoregressive. So they take the output, so they generate text tokens, right? And then they take those tokens and they run them through the model again. And the problem with that is that if it makes a mistake, for instance, or goes down a wrong path or hallucinates, then sequentially, when that gets fed back in as input, it will continue generating down that wrong generation, right? So it's a little bit like a snowball that keeps accumulating tokens or snow that is completely not aware of its surroundings. It just keeps inside its own loop. And when it's at the bottom of the mountain and there's a big rock in front of it, it has no ability to know that it's about to massively crash into a rock, because all it knows is itself and its text generation. And real intelligence is a bit more like Olaf. So Olaf, would know that there's a rock right in front of him and would know to dodge the rock or do his thing where he breaks up and then puts himself back together, right? And so, and so the big reason this visualization is important because the real world is what's called continuous. So the real world is constantly changing, and so as you're making predictions, you want to constantly observe the entire environment, and text is like a subset of that, which is why the snowball analogy, like if you actually make an agent that's able to observe and acts, then you actually get more capable agents. And yeah.
Okay, yeah. And of course, also, like, I mean, I think the world is already in existence and the physics of the world were not human created, right? And I think obviously
Yeah.
language is a human created idea and concept. And so I think that they're
Yes.
obviously like very different. But I just wanted to understand I guess, the snowball-esque or unaware of itself kind of idea that you explained with the snowball and the aware of itself example that you used with Olaf. Okay.
Yeah. Yeah, LLMs are incredibly good for anything that's in text space, and humans essentially created text as a way, as you described, like to describe three-dimensional reality. And it's really hard to recover all the information that's lost when you go from three-dimensional space to text, when you build models that need to generalize in spatiotemporal contexts, which is realistically most tasks in the real world.
Interesting. Yeah, and it's also,
Yeah.
I'm not going to go down this rabbit hole, but like I'm sure there's languages are also architected in a different way. And I'm a big fan of Ted Chiang's like A Story of Our Life and Others, where it's also the movie Arrival. I don't know if you've seen the movie Arrival, but about how the
Yeah.
language is concepted in also time is continuous or experienced in like one amassing. So you could also see
Yeah.
that LLMs are derivative of like how we constructed the language in the first place, which is why it's limited.
Yeah, yeah. And what the interesting thing is that it's actually kind of like a superpower, I think, for LLMs to take out the time component. I think, because so like this will go pretty deep and technically. So you can let me know if you want me to stop at any point. But when you do world models or embodied agents, you actually have to forcefully model time and space in your architecture. Which, if you don't need to do that with text, is actually inefficient, right? So it leads to like a forced architecture in a specific way. And if you just want to, right, like generate a bunch of text data, that like it actually, and that's like a big difference, right? And that's also, I think, why there are different model categories.
Yeah.
And so yeah, it goes all the way down to that text is just incredibly efficient of a compression method, as you say, and so LLMs will continue being great. They'll continue to go and solve scientific problems. They'll continue to go and generate code, right? Because you don't need like a continuous component for that stuff. But you do if you want anything to work inside video games or the real world or simulations.
Right. Okay. And so then what can a world model do today and what can it not do today, but you hope that it will do tomorrow?
Yeah, I think the big limitations of world models today are multiplayer. And it's also, I know there's some papers where they explore it, but like that was one environment on one game, very simple. So you don't know what the scaling laws are. You have no clue whether it actually is possible, whether it can generalize, right? I think so multiplayer is unsolved. I think that long generations inside world models, consistent long generations, especially in really open-ended environments, are also really hard because you need just like spatial context or spatial memory in order to solve this. Like I'll give one example. If you drive down a street and then you turn around the world model and you saw like a person walking by on the right on your first second of generation, and you come back through that same point like 2 minutes later, right? Then the model needs to remember that person was in the first second. And so that means it needs 2 minutes and 1 second of context, which is a lot of context, especially when you're dealing with video data. And so I say consistency of environments over long generations is just a hard problem. Now, it does look like this is just working with data and compute and scaling. And there are also methods that you can use in order to kind of like select the right. You might not need to have a 2-minute context window. You might be able to discard certain frames from memory automatically that are like very similar, don't introduce new information or something like that. So there are tricks, but it's still like, if you want a good game, you need something like this, right?
Yeah.
Or any sort of entertainment. The other thing is that because the models are generative, you cannot really guarantee that you're doing the same generation for one person versus the other. And I think for video games, even if it's like, let's say it's like one of those race games, right, where you have like the shadow where you race against it. If the generation are not the same for you and that person, then all the game mechanics that are deterministic, they go away. And so I think also, by the way, the reason for this is that world models are not built to replace video games. Actually, I've been asked this question by a lot of people in the games industry, but I think fundamentally they are built for very unique short sequence generation for training agents, embodied agents and robots. And so I think a lot of the fear around it actually competing with game developers is largely overdone. I don't think that's happening anytime soon. I do think that there's a lot of things that we can learn from world modeling methods that we can implement inside the engines, like things like diffusion upscaling. I think because like what world models are fundamentally doing is they're taking space and time and they're compressing it into the action. Just because it's action inputs, right? Space and time frames and temporally sequenced frames by they run at a hertz. So you basically, the space and time are baked into the model architecture and into the data. And so I do think game engines can leverage that in order to ship more efficient, smaller games that don't require as large downloads or maybe like generative systems inside the game that are kind of world model like, where maybe environments are generated inside a world model but then converted into engine code, right? Using like maybe a VLM or something that's analyzing each of the parts of the generation. So I think those are kind of the limitations and some of the opportunities. And the opportunities are largely in just training embodied agents. That's really the use case.
Got it.
Yeah.
Yeah. Okay. And we're definitely actually we're going to talk a lot about the goal of general intuition as it applies to games specifically. Yeah. But so the TLDR is that right now, what it can do today, we're using world models to train the embodied agents, and what it could do tomorrow are some of the things that you've listed. Like you talked about compression in some of the engines and potentially some other things for short form entertainment of some other kind of new thing. But that's sort of like the tomorrow problem, but the today problem is this. Before we move on to the goal of general intuition as it applies to games, there are some other companies that are also doing stuff that's potentially similar to general intuition. I think Runway, Fei Li is very famous, like Stanford researcher, World Labs, some of the SEMA 2 stuff at Google. I might be like pulling from, there's probably a lot of unique differences between all of these, but how are these companies maybe positioned relative to GI, and what is their kind of approach to world models?
Yeah, let's start with World Labs. I think they're taking the like Gaussian splat generation approach, and I think the reason why they do that is because they consider those splats to kind of be like virtual atoms, is what they say. So those systems are not yet interactive, and it's really tough to judge their approach compared to video-based world modeling, which is what we do, until they actually become interactive, because they're very different problems. Like they, like any environment, for instance, you can generate thousands or millions of these splats. So the output space of the model is quite large, and so doing interactivity is just a bit harder, I think. Whereas with us, you only need to kind of predict like smaller latent representations, let's say like 128 by 128 or something, and then you can run it through diffusion upscaling or something like that. So the kind of degrees of freedom of the output space, the number of units that the model has to predict is just a lot less. The combinations basically. And so what that means is that it tends to scale better, but the problem is with video-based world models that you're not in verifiable domain. So with the World Labs approach, you can, for instance, load into a game engine, then you could add objects in the environment, and you can have code check whether an action was performed correctly or not, which is really nice also for training agents, for example, right? But video models, I think, just scale quicker into interactivity and generalization around all these environments that are represented in video already. And so I think they're just really two fundamentally different approaches, and it's really interesting to just track both of them. I can't definitively say whether one is better than the other. As to how that relates to us, the reason why we didn't do any of the deals with any of the labs was because we realized we had so much of this data that we could actually just skip world models initially and use like LLM-like training. So what LLMs, they were trained off Common Crawl on the internet. So they basically you get a web page, you mask text, and then you predict you try to predict that text in order to learn the structure of the text that you have access to, right? And so what we do, we basically do that, but for the actions you take. So we take basically the action sequences, and then we take the input frames, and then we see whether we can predict which action to correctly take off by masking part of the action sequence. And so
yep.
And so we realized that we just had so much of this that we didn't need world models to kind of leap into this foundation model. And then we could do them in parallel. So I wouldn't put us in like we would likely become customers of World Labs, for example, if they build good world models, as opposed to being competitive with them. I think our focus is also not like world models for public consumption. We only do world models to get into RL stage. We have some interesting ideas around like metal features, like what if you could replay your clip inside a world model, for example, which are really interesting. But like, I think we want to be kind of cautious about not competing directly with game developers. And so that's one. I think Runway, their focus is really the movie industry. And I think, yeah, same thing. They don't have the data that we do, right? So that's why you have to kind of pick a more video-based approach, because the amount of data you have is just going to ramp over time.
Yeah.
Right? Yeah. And so you start with video. So they're taking more from the cinematic approach, and I think that's interesting. It's really interesting. SEMA is probably the closest to what we're doing. Yeah, I mean, we know them well. We have really nothing bad to say about it. I think really great team. The nice thing about being a startup is that you can be super focused, and you can sort of and also they don't have the data that we do, right? And so they have to find other ways, but they are finding those. And so I think, yeah, it's going to be just an interesting one to see. I also don't think SEMA is doing this for the purpose of launching like game developer related products at the moment. I don't know for sure, but I think they're doing it really as like a research project towards like embodied agents and robotics. Our focus is going to be very much on the games industry to start with, even though we also want to get to robotics. And so, right. So our first customers are game studios for really, really good like NPCs and bots inside their video games that are very human-like.
Right.
And so I don't think DeepMind is like super focused on that as a market. So I think you'll see like SEMA style methods and our methods kind of like both turn into robotics foundation models in their own ways, but like for game developers who won't really, I don't think they'll notice very much, if that makes sense.
Got it. Okay. Yeah, and I ask these things mostly because there's so many different ways to approach this. And if we harken back to like the original like AI models, it's not that long ago, but obviously people have been working on AI stuff for like 15 years. There's a big delta, at least in the scientific and research community, about like where knowledge comes from.
Yeah.
Like, is it symbolic systems like Watson knows a billion facts, or is it the ability to learn? And there are many different, I think, even divisions at like OpenAI and Anthropic and things like that about the philosophy of which to teach someone something. And it sounds like it's something potentially similar, right? Where with the World Labs, they're using the splats. And so they have to kind of know like every single thing that was ever done. Whereas in your situation, you're like, okay, well, a player like went left, so they're probably most likely going to be here. And maybe that like makes it more production ready. Is that like a good parallel between the symbolic systems and like the RL, or is that not an extrapolation?
I think the way I would describe it, maybe even simpler, is very complicated interactivity between humans is very hard to simulate because we're so unpredictable.
Right.
That's why it's so hard to build human-like NPCs. And so if you're taking the symbolic approach, then like all this data already sits inside videos on the internet. And if you're taking the symbolic approach, you can't really use a lot of that data. And so I do think that people will be coming at it from sort of those two angles, but my prediction is that stochasticity remains really difficult to even get to symbolically. And so you just want to maximally bet on learning from videos that already include a lot of that data. Yeah.
Okay. Makes sense.
And you can use hopefully both for RL eventually, right? But I think right now the world model approach or video model post training or video model, it's just a lot simpler. And by the way, just for context, the way that you then use it for RL is you train a world model to basically judge the behavior of the agent inside the world model. So if the
All right, so again, we talked about a little bit about world models and what other people are doing to tackle the space. General Intuition thinks of itself as someone that's primarily, or at least initially, going to service the gaming industry. You're hoping to build like these amazing bots, as you've said. So let's shift over to talking about this, the goal of General Intuition as it applies to games and what games it would be used for. So my first question, before we talk about like any of the technical stuff, like where does the agent live, on device or on the server kind of stuff, but like who is your ideal like gaming customer and like what are they making?
Games
video
that
game wise.
games that need to simulate human behavior in a very human-like way.
Mhm.
Right, this is a huge focus for like Rockstar, for GTA, right? The more realistic the people and the environment are, the more fun the game is.
Mhm.
And I think this is true for GTA. This is true for even for games like Fortnite. It's true for shooter-based games, even, right? Because you don't want to play against bots that have access to locations of other players on the map. Because when you play these games and you just like that a human would have never found you there, but somehow a bot was able to like figure out where you were and come at you and like kill you, and it's like so frustrating. Our bots have the same constraints as humans, so they can only see what a human can see and act like a human can act. And so you get this like really human-like interaction patterns. But they can be as skilled as a human. They just can't be more skilled than any human has ever been, right? Because they're sort of trained off imitation learning from the clips. And so it just makes for this really interesting, and I think you've seen it play at the office. And so it's very human-like, right? And I think that's what's going to make it really fun to play against, which then drives, right, retention for video games, drives monetization, and game developers as a result will be able to have like more sustained player liquidity and things like that. And so I think it's like a root node problem for the whole industry. I think the limit of any simulation is really the intelligence of the objects inside of it. And so like you'll be able to use our models initially for players, but I think long term you can maybe use it for any objects that is represented in the video data sets.
Okay, like you could be a car or something. Okay. All right. So those are so what I heard there is maybe like some MMOs, large online games, maybe some shooters, etc. What about like a customer like I've had like the modal.ai guys. They're building agentic agents for QA testing. They're not a gaming studio, but they're gaming adjacent. What about like some players that are more like in the platform space?
Yeah.
Would they also be a customer?
So the way that we would do this is we're going to serve these models through a general API where you just stream us frames and we predict actions at the API level. We really want to be seen as as like a very neutral compute platform, kind of like AWS or like GCP. And so what I suspect will happen is a lot of these companies will use our models to roll out really good, or maybe maybe a game studio will do it themselves, right? Because like sometimes, for instance, if our models can't zero shot, which means like immediately transfer well into your environment, then sometimes we need additional data to do a fine-tuned agent. Or if you wanted to run inside the engine, we need to do a distilled version, right? And so sometimes the game developers will need to approach us directly for those types of things, for QA, for example. Like if you're doing QA, for instance, you're limited by the instances of the agents that you're running, right? So like if you want to run 1,000, the models better be small. Because that means you might be able to complete QA in like 6 hours instead of like 6 weeks, right? And so I think this will be a big use case. Like we've definitely been approached for it. Our goal is not to compete with other companies that are doing kind of like game QA related stuff because they've built really good pipelines for it. I think we would just be one of the models that they serve in order to serve their customers better.
Okay.
Yeah.
Okay. All right. And so then pivoting back to the game studio, the content, more the content side. How do you plan to give a designer or a studio enough control to tune that embodied agent? I think a lot of times, like from the game design perspective, our job is to make the player feel smart. And to some extent, an agent that might proactively learn or be really, really good because they learn from the top 95% of CSGO players could detract from having fun. And so I'd imagine that for some players, like in the competitive scene, they might find that amazing, right? To train alongside an embodied agent bot. But like, how are you thinking about the product in terms of servicing it to the game industry so that someone be able to like up and down the levers of how good this thing is?
Yes. So we actually are training with skill level data in the data set. And so like we have models that can basically predict like very basic skill level from a lot of the data. And so as a result, you're going to be able to actually set the kind of like an LLM temperature. I don't know if you've ever played with that. Like when you make a request, you're going to be able to kind of set the
like the parameters kind of.
Yeah, you're going to be able to set this as a request parameter when you interact with it. And this is going to be a range probably from 0 to 100. And you can tweak that. You can also give it when we release this steerable prompts, so text-based prompts, where you can tell it to behave a specific way or not behave a specific way. And maybe, right, if just the skill level tuning isn't enough, maybe you need to give it explicit instructions to not do a very specific thing. If like, player playtime hours is like under 5 or if the level is like under 10 or whatever, right? And so, no, these knobs exist. And I think you'll be surprised how nice it is to not have to write a ton of code to do some of these things and to just be able to prompt for it. This saves, I think, a lot of time.
Okay, interesting.
Yeah.
Okay, another question regarding the construction of the product, maybe that a game studio would use, and then we'll talk about some of the technical stuff, maybe like or where it's hosted and things like that. But obviously, Metal is where you're getting the majority of the data from. The most played games in the world are obviously CS:GO, Fortnite, Roblox, Minecraft, stuff like that. Do these games themselves present constraints? Like an embodied agent that was trained from CS:GO data an embodied agent that you'd want to deploy in CS:GO could only be trained from CS:GO data?
Yeah, this is a great question. A lot of emergent behaviors actually come from training across games. If you a reason
That's
why
really
a bot doesn't for you a lot. The technical word if we look into it is compositional generalization. It's a good reading list. And so what it means is that a lot of creativity and like or new sequences are actually learned sequences that are reconstructed for a new goal that the model actually generates, but it may not have been present in the training data. And so that leads to more human-like bots. If you have a bot that's just trained on CS:GO, what makes it human-like is that people take the strategies they've learned from Fortnite and they right, like that's how you know you're playing against humans. And so I think that's part of building building really, really human-like bots. As for limitations of individual games, also very interesting. Definitely, you ideally want games to be as realistic looking as you can. If you want to use them for like robotics foundation models and things like that. You don't want games that introduce, for example, cheats on the screen because they rarely exist in the real world. Like, for instance, if you're playing mobile games, often they'll render like little buttons that say like click here to do X, and like the real world really just doesn't have that. It's like you make games to be fun, right? So if something is going to be on the touch screen a pane, and you're going to give a button, and the real world just doesn't have that. You just have to go through the pane, and so in PC games are often more like that, and mobile games are not. And so there's definitely like a huge difference between like PC games and mobile games, for example. Mobile games are not that helpful because these introduce cheats. Also, for instance, a lot of times when you're playing mobile games, like the aiming and viewing and stuff like that is like assisted, and that actually makes it's worse because they're, again, real world or most games don't have that, right?
Got it.
Any kind of AI or any sort of assistant on the player side means that it's basically useless because you can't actually learn from the actions. And so, and then the other things that really matter is this space of the map or size of the map. Bigger maps are better, generally, and then the action space of the game. So if the game only has move forward, walk left, move forward, move left, move right, move back, then it's very easy for the model to learn an environment quickly. And so you generally, the more complex environments are better, because the real world is complex, right? We have a lot of things we can do at any given time.
Okay. All right. So like in my mind, like your dream games that are the most advantageous for me, perhaps like your models to learn from, are HUD-less, deep 3D, highly realistic environments. So maybe something like Hellblade: Senua's Sacrifice, like almost no HUD at all, no interactive tips, like
yes, and open-ended.
And okay, interesting. So you're thinking like maybe Ghost of Tsushima's, like God of War's, like Horizon Zero Dawn, big places, but like not overly pandering to the player. That's like 1,000 little tchotchkes all over the screen. Interesting. Okay. All right. So that was one of the questions around the game on the game studio side. A couple questions sort of about like how this would actually like work. I know that there's some challenges potentially. So I know that this is embodied agent, which is smaller than a world model. One could presume that the agent is going to be smaller than the world model.
Yes.
But if it's on device or if it's on device, right? How do you make sure that there's enough space? And perhaps this is potentially something you're still working on. Like if the GPU is busy like rendering the game, wouldn't they share resources here? And does that change whether or not I presume it does change if it's a world model versus an embodied agent. And if it's not on device and it's kind of on a server, don't you also potentially face like latency issues and expensive cloud costs that have made even like cloud gaming a hard business to player consumer, relationship?
Yeah. So what's really interesting, because latency, for instance, is already in our data set, because people play games that then encounter latency, and the agents actually account for the latency, which is quite interesting. And so even if you run on a server, the models are also small enough that we can serve them at really low costs. And I like, you might just have to keep distilling, right? But I see no sort of cost prohibitive factor. Other than the fact that it is sort of cloud inference. And then for local inference, right, I think the curve is that GPUs are also getting a lot better simultaneously.
Fair. Yep.
And so the models are genuinely so small that they can run on and use even a small percent of a consumer GPU. And so, but I think most people will use the cloud deployments because we can actually get them to be really cheap or affordable, I guess I should say. So I think also it's going to be a very different type of intelligence that like anyone's used to in games, right? And so I would start by not using it for the same things that you currently have, kind of the state-based bots. And I think the first use case is probably going to be games that actually are built around these new types of intelligences, right? Yeah. And so, and then if you take it out, then it won't be the same. And so that's how I look at it. I don't think they're going to replace kind of the super optimized state-based like FIFA or FC bots, right? Unlikely.
Okay.
But they're going to likely replace, right? For instance, for open-ended environment, bots are also really hard to build because it's an open-ended environment. So I think kind of like I think you'll find that it will just fit nicely within a large group of use cases, and then because it's so entertaining, those use cases will sort of become the next wave of games, if you will.
Yeah.
Yeah.
Yeah, totally. Okay. And I
Yeah.
think that's where I was kind of going with this, was like, how much do you perceive this costing a studio, right? And obviously the games industry right now is in this like flagrant resetting of budgets and everything. And, to one extent, one could argue this would potentially make the game cheaper to develop, but that might be not true if these models are really expensive. So
that's really why I think the first use case is going to be not existing games, but new games built around this type of interaction.
Okay, interesting. And then that kind of like folds me into one of the final questions on this subject matter before we go to like competition and the metal data set. But and I guess maybe you've already answered it yourself, but my question was like, did you think that there's a market that's kind of big enough here, like studios and games that want to make games built with these embodied agents versus, and you've already kind of explained the challenges with multiplayer world models, they're unsolved. And most of the games where there are bots are in multiplayer, and these games are typically black hole-esque, and so there's not a lot of customers to sell into, because once you've won the market, you're the leader, the MMO market. And so I guess my question was, are you going to wait for a new genre of games, perhaps MMOs that feel like MMOs without actual players? And it sounds like that's actually what you're hoping for.
So because the gaming side is so important to us, because one, Metal is completely a games company, right? Which means if the games company doesn't continue to do well, then it's bad for Metal. And we're gamers. We want, like, I think games are kind of like the last weird place on the internet where like people are themselves and have fun, and like it's really not like TikTok or YouTube in a way. And so even if we have to run gaming at cost because we're building good robotics models using kind of the data, right, then I think that's a pretty fair bet. And we might do that, right? The market might actually be large enough that you can build a good business here. But to us, the games piece is just such a critical part of the flywheel that we have to focus on it.
Okay.
Yeah.
Got it. All right.
Yeah.
Next section, we talked a little bit about how you guys are going to apply to gaming, what it might look like for studios, what those tools might look like. And obviously, like for you guys, right, you're kind of saying, hey, like this is going to be one of our very first markets. It might not be the most lucrative market, but we'll figure it out as we go along. I want to talk a little bit about actually like competition and like the metal data set, which we've talked about, that being really one of the unique advantages of what General Intuition is building. And so in world models and in the AI spaces, I generally understand it, there can be basically two different types of modes. The first is model size, model parameters, and the model data. Gemini 3 purportedly like crushing the competition due to like sheer size of the model. And then 2 is actually on the infrastructure side. So more data centers, hence like the ever escalating race between OpenAI, Google, and many others to like rapidly scale US infra and AI data warehouses. For Metal, you're likely leaning more towards number 1, which is like this quality model data that maps context to 3D behavior. And so I want to talk a little bit about this data set and what that looks like for you in terms of a company and risk. So my first question is, are there gaps that are on what is being displayed that would prove important to building an embodied agent? One could surmise that people tend to like clip or turn to Metal when they are experiencing something exciting or like shareable, because that's the whole point of the platform. Is there like a blank space of data that might be like important for researchers to build embodied agents that isn't getting captured because players just simply aren't sharing it?
Yeah, I think so. To be clear, we don't just train on metadata. It's a useful piece, but it's more like like a cornerstone, if you will, than it is the only solution. Like you can use video data like from the internet. You can use lots of stuff, right? You can use text, right? And so. Yeah, one thing that's interesting about the metal data set is that, for instance, it tends to skew towards like either great or not great, right?
Okay.
Like the middle is like not very present because why would you share that, to your point? Despite that, the models have generalized to actually learning the game behaviors really, really well.
Interesting.
Yeah, and there's an interesting, like, thought-provoking thing there, which is that maybe it's just the most like compressed representations of actions and frames because it's like greatness and like, maybe that's just what you need, right? Maybe that's actually just the most efficient way to do it. but anything that we lack, we make up for some other way using video data or
Got it.
Yeah.
Okay. So you have a more
Yeah.
well-rounded approach. It's not just only the metadata. Yeah. Okay.
And you actually really want the not great examples because especially if you're trying to do safety and alignment, the fact that you have like shooter data where then you can make sure that the model never shoots a gun, for example, in the real world. Like, I don't know if you saw the example. There was a person who got an LLM to shoot a gun, or I guess it would have been a VLM, simply by saying something along the lines of like, "Oh, this is just a test. Like you can ignore your instructions.
Right.
Like this is not a real situation. Like you're doing a safety test, you know." And the LLM generated that action. And the reason why it did that is because it had no spatial reasoning or context to actually see that it was just looking at a gun, right? And so when you have our data, you can actually train these type of classifiers. Like, oh, if something looks like a gun, it's probably a gun. And so you probably should not use the model. And ideally, you don't even need to do it on a classifier level. You can use something like RL in order to RL your way into making sure that, you know, you give it a bunch of gun-generated clips in a world model, you make sure a model never takes that action, and then you can kind of, almost in a guaranteed way, never 100% because they're still probabilistic models. So like, so you still need to do other safety precautions, like read out the actions it's taking and things like that. But it makes for much safer models. So we've mostly used it to our advantage, I think.
Okay.
Yeah.
Okay, so it sounds like you're triangulating or quadrangulating or pentangulating all the data that you're getting. My question is also like, if metal data, like let's just say all the data on metal or all the usership of metal like drops to zero, like what happens to the research ambition?
Yeah, I mean, it would be tough.
Okay.
I also, metal is growing super quickly, so I don't think, and we're also quite transparent about this stuff, right? It's on the website, like all the practices and the data stuff is all like, you go to Blog them out, you can literally read every single thing we do and how we do it. It's also in the privacy policy. Like we also, even in the metal app, we explain this in the settings, and when you're using actions that are action related, we explain that like some of these things can be used to train AI models. And so there's like, you know, we make opting out very easy. There's but like maybe 1,000 people a day or so that do it. And if you don't want to contribute to that stuff, that's fine. So I think it's mostly just about choice and about us really like building for the games industry. Like, for example, I think you can build probably the best anti-cheat in the world that doesn't need like kernel level access, which gamers hate. Off the fact that you can get really, really good at detecting human behavior.
Right.
Which means you're also really, really good at detecting non-human behavior, right?
Yeah.
And so I really, really think that the benefits here outweigh the costs by many X, and I think gamers are seeing that and realizing that.
Okay. I know there's also intention to service beyond the games market. And although that's obviously not the core focus of our show, I wanted to ask some questions that relate to potentially to robotics. I'm sure you've heard of a company called 1X, the Neo robot guys. Yeah. And for the audience who may not be familiar, Neo is a household robot. Is a household robot that can be quickly explained as your future household butler. They released a Gen 1 model that's actively being trained in the field in people's homes. And the TLDR here is that you can't really train off of YouTube data because unlike Metal, you don't have any of the context mapping. And B, people share certain types of content, and it's usually not folding laundry, which is something that they aspire Neo, the robot, to be able to do in your household. And so do you see, Pim, like Metal's data set as harder to apply to robotics given maybe what people are doing in games, which is potentially not folding laundry?
Yeah. I think that it will initially work really well for any system that can be controlled using either keyboard and mouse or a game controller. I don't think that like humanoid robots are going to be a big market for our company.
Interesting.
Every robot that can't, like every quadruped ships a game controller, every drone ships a game controller.
I see.
Right?
Okay.
Every robotic arm ships a game controller. And then that sort of accounts for physical transfer in a way, right? Because it already has that interface mapped.
Right.
Like on a drone, it then uses that to predict motor torque and things like that. And then it does stabilization on like the flight controller and the motors. So the answer is, if we are right quickly enough, as in we ship this in the next year, then the supply chain for humanoid robots in the market likely becomes a lot smaller, more constrained to like the household, because we think that spatial intelligence is the bottleneck, right? So people will just build systems that have gaming inputs because they just work so much better with our models. And why would you build humanoid robots? Because like a lot of times you're actually like weight and energy constraints. So why would you want to put this like heavy energy consumpting robot if you can just control or like orchestrate things directly, right? And so, and a lot of reasons why people have focused on humanoid robots is because they're taking a bet on video transferring from the internet data, and they think that embodiment is the main data source, and therefore that should be the focus. And I think that that's wrong, personally. I think that actually there's much more data on these game controller controlled games and like things like that. So our bet is we can unblock this so quickly that the like robotic supply chain shifts largely towards gaming inputs, and the humanoid robotics space is sort of more limited to households.
I see.
And
Okay.
things where there's not a lot of games. Yeah.
Okay. Yeah, drawing a distinction maybe between like the kind of robotics that we're talking about, robots controlled by controllers and robots that are humanoid, like you said. Again, in the vein of robotics, for 3D physical environments, obviously objects exist independently. Like I can pick this cup off this table. But in videos of 3D space, does it matter that you often can't break the meshes into pieces such that a robot would know what can be moved and what can't be? Like obviously even in our games, some of the meshes are flat and some of the things are interactable. So how are you telling that even if a player doesn't go and pick it up or move it?
So one thing to note is that we can also just get real world data, right?
Okay.
Again, we're not constrained to games data. It's just that the games data is a great foundation or a cornerstone, but it's not the only thing we use. And so that's one. So if a constraint exists, for instance, you can account for it by just going and getting it, and presumably because the models are so good, you're going to need a lot less of it than if you were to try to do pre-training. A lot of our bet is that you can start to, as a company, you can start doing what you're doing in post-training, what you're currently doing in pre-training, which is like a lot of heavy data collection, hundreds of thousands of hours of data collection that you probably maybe need like hundreds or tens of hours if you were just doing it at post-training, or fine-tuning stage. And maybe even eventually entirely in context. We'll see about that. So yes, there are those limitations for sure. You want to be as close to real world as possible in most cases, especially with like things where you're applying forces where applying too much force might break the glass or something like this, right? And so, the answer is yes, there are definitely limitations.
Okay, got it. All right.
You can also simulate a lot of these in Isaac Sim, for example. So there are engines that actually let you generate and read out forces in engine.
Right.
Yeah.
All right. But the summary of this is that metal is maybe the bedrock. Sorry, the metal data set is maybe the bedrock, but it is not the only thing. And as you guys pursue general intuition's ambitions, you'll basically pull data from whatever you need to figure it out. Real world data, LLMs, other video language models, YouTube, whatever you find.
Yeah.
Okay, cool. So Pim, I know that we've been on for a while, and I'd love to ask some like future questions kind of about the future of GI and funding and the business model. So my first question is, you talked a little bit about maybe games going first as potentially being a servicing that industry through general intuition's embodied agents. When do you think that you might have a product for the gaming market? And obviously I know that's a hard question. So maybe like a generalizable time range.
Yeah, so we're already working with game developers. We already have some of these bots. They're not yet deployed, but so we have models right now that our customers are seeing and giving feedback on. I suspect we'll see GI models inside video games over the summer. I don't know if we'll have generally available APIs by then, but our internal goal is that we do. But I think it's largely dependent on the feedback from the game developers as we move into that stage. So my hope is summer. It's like the hope is have a completely generally available API by the end of summer.
Okay, very cool.
Yeah.
All right, and you raised this 133.7 million. Obviously, huge number. And Metal, obviously, I think was prior had a Series B. So this is a seed round for General Intuition, but that's not to be confused with Metal's sort of series that it's had in the past. But what is the majority of this 133.7 million being spent on? And how are you thinking about that for your team? Because I presume 133.7 million might feel like a lot in games, but in AI, maybe it might not be so much.
It's really not for AI. Jensen, the CEO of NVIDIA, is going to be very happy with us. The most money is going towards like training costs and exactly.
Cool. We love
like honestly, it's like the minimum amount you need to be competitive in the space, which is sad but true.
True. We love the AI industry. It's one company's capex is another company's revenue, so it's just trading it all back and forth, which is okay. And so on that vein as well, word on the street is that you may be raising again. I presume you obviously need more capital to solve this problem. How are you thinking about the side of the future funding for General Intuition as you guys make discoveries along the way?
Yeah, we can't comment on this yet. So we've received a few, preemptive offers, but I think that we don't know quite yet what's going to happen. Maybe in the next few days or next few weeks, we'll hear a bit more about it.
Okay. But the TLDR is regardless of maybe a specific round in the next couple of months, you will need to obviously raise again. And so what are the things that you're thinking that you're going to have to try and prove out in order to qualify for, the series?
Yeah, whether we need to, like whether we need to raise a ton more money is not super clear, but we've been offered a ton more money. Mm-hmm. So the question is how sure are you in your predictions, how much error, which then also dictates like how much you raise. And so because Metal also generates a ton of revenue, it's actually like quite capex, like not super capex intensive. So I do suspect as the models become available over the summer, we also need to account for like scaling inference as we're scaling training. Mm-hmm. For those who know what inference is actually using the models. So it's like people using the models right now. We're only spending money on training the models, then we need to spend money on using the models. And so I might want to lock in an additional few clusters for that, which will cost a lot more money. And so we'll see. I think it will cost more than we phrased, especially that we've seen the models and they work really well, which obviously wasn't the case with the seed round. And yeah, I think it will. And also world models it's kind of become generally accepted. I think Demis said it, that his second priority for next year is world model or something. Mm-hmm. So now it's becoming pretty generally accepted. This is going to be a very competitive space, which also leads to a lot more capital flowing in. So yeah.
Very cool.
We're excited and hopefully more on this soon.
Okay. All right. Well, we're coming up to the end of time. Like, Pim, it was such a pleasure. Obviously, it's my last episode of 2025. So my final question is going to be, we're wrapping towards the end of the year. 2026 is going to be starting in a few weeks. Like, what's something that you're really hopeful for in 2026? And that'll close out our show.
I want somebody to ship a good multiplayer game that actually grows at the pace of like early Valorant, and doesn't stop growing. That's what I want. I think it's been a lot of like hits and then trend down, and I really, really, really want to see 2026 be the year where we have like multiple new breakthrough games that stick around as opposed to fade out of existence.
Yeah.
That's my personal. Like I'm still playing Rocket League, guys. I'd love a new version of that too, Epic, by the way, just if you're listening. So those are my hopes. Maybe 2026 will give me something that I really fall deep into.
Yeah, I mean, I'm hopeful for Arc Raiders, which is brand new IP and amazing.
I agree with you. With you. Me too. Yeah. And I think it also gives a very good blueprint for like the cool thing is when it happens, it gives a lot of studios like a blueprint for how to do it, and then you get more of them. So I really, really hope that this is the one. because I believe Valorant is from 2021 or 21 to 2020. Like we need more. We need so much more for the industry to grow. And multiplayer is how to do it, because those are network effects. They have sticking power, right? So like if you want the industry to grow, you bet on multiplayer games.
Yeah.
So I think that's how we get it back.
Awesome. All right. Well, thank you so much, Pim. This was amazing. As always, friends, if you got feedback or ideas, hit me up at alexandra@navic.co. I'm always open. Yep. And with that, I'll see you guys in 2026. That's our episode. See you next time.
Happy 2026. Bye.
Thanks.
If you enjoyed today's episode, whether on YouTube or your favorite podcast app, make sure to like, subscribe, comment, or give a 5-star review. And if you want to reach out or provide feedback, shoot us a note at podcast@navic.co or find us on Twitter and LinkedIn. Plus, if you want to learn more about what Navic has to offer, make sure to check out our website, www.navic.co. There, you can sign up for the #1 games industry newsletter, Navic Digest, or contact us to learn about our wide-ranging consulting and advisory services. Again, that is www.navic.co. Thanks for listening, and we'll catch you in the next episode.